Hi, good morning everyone. This is Kumar. Welcome to this channel. Today, I would like to explain about linked. A list or sequence is an abstract data type that represents a countable number of ordered values. It means list or sequence. It is the any number of values or any characters. It can store ordered values. The ordered means the sequential flow of the data. The mainly lists are implemented two ways. The mainly lists are implemented two ways. That is the by using arrays. The previously how to implement or how to declare or access the arrays. And at present, discuss using linked lists. Present linked lists. It is also like array elements. What is the differences of the arrays and linked lists? Let now class. Array. An array is a basic abstract data type that holds an ordered collection of items accessible by an integer index. It means like an array, it will store number of values or characters or any data based on the integer index, that is starting with 0, 1, 2, 3, like this. These are the integer index. The type of storing values using arrays. And another one, linked list. Linked list is a data structure that can be used stored linear similar time. Similar time means it is also same type of data. Now the arrays and lists. Now about the clarity about the what is the advantage of the lists? It means linked lists. What is the advantage of the arrays? What are the disadvantages of the arrays? What are the disadvantages of the lists? Now the first one is fixed size. In array, the memory is allocated at once based on the size mentioned using the array declaration, that is called static. It means, for example, we are using int a of n. That is the a variable, it holds only 10 values. It is a fixed size. At the time of execution, it cannot increase the size of the array. That is the static or That's now lists. The memory allocation is dynamic. The size of the list increases as the elements are added to the list. Because of at the time of execution, using dynamic memory location like malloc, calloc, realloc functions, it's added any number of elements. So the advantage of the linked list arrays is a disadvantage. The second, insertions and deletion operations. The arrays expensive because of, for example, array is four values. It is 5, 6, 8. Now, the insertion and deletion operations is an expense because of yes, I'm adding or insertion 7 in the middle of the position after the sixth value. It is very expensive because of first before insertion 9 is moved to the next location and 8 moves to the next location, then 7 insertion or pass. Only for the 4 elements in the array. It is a 3 operations can perform. 2 operations, it's move next positions, 1 operation for insertion. In case it is in a thousands of values, it's very difficult. That is means a very it's take time. That is the expense. In case you can delete any value. For example, if the second position value you can try to delete, then move the seventh value to previous location and 8 also some previous location and 9 also previous location. Then the last value, last location is it is also very expensive. That's why using arrays, insertions and deletion operations are expensive. In linked list, it's very easy. How to insert and how to delete later I will discuss. But isn't it very easy to insertion and deletion operation. Second, next point, cache array have a better cache, have a less cache. The cache it means the very fast accessing memory. That is storing area. It's a very easy to access. Better chance to arrays, but have a less cache because of its dynamically stored data. Next one, random access. The random access is possible through indexing. That is also explained. For example, array, for example, 5, This, for example, like it's an variable A. The random access. Random access is possible through index. It means the indexing of 0, 1, 2, 3. Now, I'm accessing A of 2. It's directly access the 7 value, third position. In case I'm accessing A of 3, that is 8, that is the fourth location. In case A of 99, it is 100th value, you can directly access. The random access is possible through index. Based on the index, it can access any value in the array. The one advantage. Random access is not possible because why it is not possible later I will discuss. Extra memory. The extra memory space is not required because of at the time of declaration it is assigned the fixed size. So the not required for the size. Sorry. The extra memory space is not required because its a value is directly stored. 5 is only for the integer value, so it's stored in 2 bytes. Like the same type, any type of data structure, data type, it is possible to store. No extra memory usage. The extra memory space for pointer to the next node in the linked list required because in linked list it must store the next node address, present node, next node address is stored to the present node next. That's why storing of address memory is required. That is the extra. Next one, the continuous memory location. The elements are stored at continuous location because of arrays is in a static. Is a allocate memory in continuation in memory. In linked list, it's not possible because of it can allocate memory dynamically. That's why its space are allocated in different areas. So it is not stored in continuation locations. It's a random locations. Arrays store continuation location because of it's in a stack. These are the main differences of arrays and now what is single linked list? The single linked list or SLL. SLL is also called a single linked list. Single linked, the sequence of elements in every element has link to its next element in the sequence. Each individual element in a single linked list is called a node, and every node contains two fields called data and next. This is the node. In this node, the two parts, one part are using data, the actual information. The data is nothing but an actual information. Store original value. The actual information is stored to the data part. And the next part are using address of the next node. Address of the next node. That is the linking to one node to another. Okay. Single linked lists nodes the two parts, data and next. Data is the original data, that is the actual information, and next is representing for the address of the next node. Further, you can create a node that address is stored to the present. That's why it is in a extra storage area. The arrays is only using data, the actual information. The addressing memory is not required for the arrays. In this linked list, it is a mandatory field. Consider three elements 10, 20, and 30. For example, in a single linked list, the address of the first node of the list is always stored in a reference node, now as the first, and the next part of the last node in the list must be null. Null is representing for the end of the node. In this example, the initial representation of addressing, that is the 2014, 3014, and 4014, because it's allocating randomly allocate space. That's why different locations it can store the data. It is linked to next field, that is the addressing field. So the actual values 10, 20, and 30. This is the node. This node address is the 2014. This node address 3014. This node address 4014. They allocate memory in different areas. But the first node have actual data and next node address, that is the 3014, stores the first node next. The next is it's in a variable. Okay. The second node, the value 20, but next store the next node address, that is the 4014, and the next node value 30 is have no next nodes. That's why it is in a next null. In case you can create another node, this is for 2020 address. For example, the by default it stores null value of the next. This is the next node. So the 2020 address store the previous next. So null is overwrite to 20. It's a link up. The first node, the next, the 040 is moved to the next node. So it is a value of 20. The next 4014, that's why it's the next node. It is a 30 and it is a 2020 is moved to the, like this. Create the nodes and so traverse one node to the. In C language, a single linked list can be implemented using structures and pointers. The structure declaration of single linked list, like struct, is a keyword, node is a structure variable, int data is the member of the struct node, and another member struct node pointer next is the another member. The two members data and operations of the single linked list. The basic operations, the important operations. The the first operation, creating a node, the mandatory, creating a node, and the next operation, adding nodes, adding a node. Another one, displaying the nodes. It means the actual data or displayed. And next one, inserting node at begin. It means, for example, have an three nodes, links onto another. In this, insert node at begin. It means at the starting position. Is for the inserting at. Insert a node at end. It means adding new node for end of the list. And another one, insert node at specified position. It means, for example, you can add at second position. So this link is to this. The specified position. The same way, deleting node at begin, it means starting node, deletion, and deleting node at end, it means delete the end of the node and counting the number of nodes. Number of nodes actually 1, 2, 3, 4. That is the counting of the. These are the main operations of the single.